radical. We already talked about this, right? So when we did our fraction exponent laws, we started about radicals. We started learning about radicals. So there's a little bit more info there in case you forgot or you missed it. A radical is this little sign, right? This thing that goes like down and up. We call that the radical sign. So anytime you have one of those, you have a radical. There's three parts to a radical. The first part is the underneath. So if it's underneath the little arm, the radical sign, we call that the radicand. The next part was the little tiny number that goes like almost on, I like to call it the arm. Like it's on that little arm of the radical sign. This number right here, it's called the index. If it's not there, what is it? It is equal to 2. Perfect. Remember, if the index is 2, we don't write the 2. So it'll be invisible. The third part, which we're going to talk a lot more about today, is the number in front of a radical. So it's technically not part of a radical. This number, the 5, is the coefficient. The coefficient just means 5 times the radical. So this would be 5 times the fourth root of 2. That's what that coefficient in front of means. Right? It's multiplication. Cool, that should be a review. We talked about that 2 days ago, right? We talked about all these parts of a radical. We got 2 questions where we're just going to fill things out. So the first question says the index is. So if you're looking at that, the index is this little number right here. The index is 3. The coefficient. The coefficient is this number in front. The coefficient is a 2. The radicand is the number underneath. The radicand is 6. Perfect. Now, there's two types of radicals. There's radicals that have coefficients, and there's radicals that don't have coefficients. This radical has a coefficient. Because it has a coefficient, we call this a mixed radical. And that's a new term for us. So a mixed radical has a coefficient in front of it. All right. Question 2. We look at that. The number 10 represents, so 10 is the radicand. Right? The number underneath the sign is the radicand. The 3, which is this little tiny number right here, we call that the index. And this question doesn't have a coefficient. There's an invisible 1 there, but 1 times anything doesn't mean anything. So this does not have a coefficient. When a radical has no coefficient, we call it an entire radical. And that's what today's going to be all about. Today's going to be about going from mixed radicals to entire radicals and entire radicals to mixed radicals. We're going to convert them. Like I said, it's probably, if I was to come out with like 5 or 6 important skills in Math 10C, this would be one of them. When you get to grade 11 and grade 12, you should be converting radicals like nothing, just like adding and subtracting numbers. It should be almost automatic. We're going to start with converting radicals from entire radicals into mixed radicals. From entire into mixed. That means we're going to go from no coefficient into has a coefficient. To be able to do this skill of converting from no coefficient to having a coefficient, you're going to have to use perfect square numbers. So yesterday we did an entire lesson on perfect square numbers, right? That was like 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, and we made a little chart. Okay, we're going to make that chart again today. I'm going to put it up on this board, and we're going to refer to this chart a lot today. So I'll put the chart right behind me. You don't have to do 1 squared. 1 squared is 1. It's kind of irrelevant to us. Let's do the first 10. So 2 squared equals 4. 3 squared equals 9. You're going to want this chart. 4 squared equals 16. If you want to use the one from yesterday that we built, you can. If you want to rewrite this out today, not a bad idea. I'm only doing the first 10. So 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. Beautiful. I call that my perfect square chart. You will not be provided your perfect square chart on a test. You will have to be able to make it yourself. Or just know those numbers off by heart, one or the other. And typically what I see is on tests, the very first thing people do is they write a chart on the side of their paper so that they have them. So it's like, oh, okay, I know those numbers off by heart. They're written down for me. Cool. Giving you a minute. I see people writing that down, which is important. You're going to want to write it down, so I'll give you 20 more seconds. Yesterday we were taking numbers and we were rewriting them. Remember, we were taking numbers like 50 and we were rewriting them as 25 times 2. A perfect square number times something else. That is exactly what we're going to do today. So the reason we're doing that is because of this little example here. The way we were yesterday saying, okay, take 32 and rewrite it as 16 times 2. Well, that actually works for radicals too. So if I have a radical like 32, I can rewrite that radical as 2 radicals multiplied together. I could do 16 times root 2. And the reason why that would be beneficial to us is because now we've created a situation where one of those radicals can be calculated into a whole number. Like if I think about this, the square root of 16 equals exactly 4 because the square root of a perfect square number is a whole number. The square root of 2, not so much. If you put that in your calculator, it's a decimal. Remember, it goes forever. So we actually leave that as a radical like this. And what we've done is we've gone from an entire radical with no coefficient into a radical that does have a coefficient. We call that simplifying. You're making your radicand a smaller number. And you do that by breaking it into 2 numbers, like we were doing yesterday, and then calculating the one that's perfect. We'll do about 8 examples together, and then I'm going to give you some time to practice it, and then we're going to convert the other direction from mixed to entire radicals. Okay, I'm going to zoom in on this one right here. Here's how we do it. So I have the square root of 20. My goal is to simplify it or write it as a mixed radical. To do that, I have to break that number 20 into 2 numbers that multiply together. The one that people will always do for me, don't write this down because it's wrong. People will take 20 and they'll say, oh, 20 is 10 and 2, which is true, but not useful to us. It's not helpful. The reason it's not helpful is because the square root of 10 is a decimal, and the square root of 2 is a decimal. Neither one of these are perfect square numbers, which means I can't actually calculate them. So 10 and 2 is not what we want to turn this into. Instead, we want to try to find a number from our chart that can divide into 20. Yep.
Would it be 4?
Bingo. 4. There we go. I was pointing the wrong 4. 4 can divide into 20, and it divides in 5 times. That means I can take the square root of 20 and I can rewrite it as the square root of 4 times the square root of 5. This is beneficial to us. The reason it's beneficial to us is because whichever number came off the chart, 4, can be calculated. The square root of 4 equals exactly 2. So this will change to be exactly 2. The square root of 5 cannot be calculated. It turns into a decimal. We don't want to turn things into decimals. We want to have perfectly the square root of 5. That thing is a simplified radical or a mixed radical. Now you can see why that skill yesterday became useful, right? Breaking numbers into 2. It made no sense yesterday. Today it's like, oh, I get it now. Yep.
Why did you skip the second step that it's just
Yeah, that's fair. So what he's referring to is I did this. Give me a second. They would have had this step. Like that? Yeah. So they just showed one more step than I did. I go from here right into breaking into 2 separate radicals. What they do is they show you broke 20 up into 4 times 5. And then there's a rule that says you can break radicals apart if they're multiplying. I just skipped that step. But it is technically there. I just didn't show it. All right, let's try another one. We got the square root of 48. The numbers are going to get weird, and it's going to be hard to figure out what divides into it, right? So just try it. So go 48 and find the biggest number that's less than 48 on your chart. It's 36. If you go 48 divided by 36, it won't work. If you go 48 divided by 25, it won't work. You'll get a decimal. But if you go 48 divided by 16, it does work. And you always want to try to find the biggest number. So start from the biggest you can go and work your way up your chart. So for us, when I did 48 divided by 16, it equaled 3. That means 48 can break up into 16 times root 3, like that. That's an important step. I'm just going to pause for a second and ask if you feel like, I don't know where that 3 came from. I don't know where the second radical sign came from. Like, if there's something that's bugging you, this is the time to ask. We'll try to keep it math related. Something else is bugging you. We'll talk about that later. All right. The reason we did this, one of those radicals is like a perfect radical. That's how I describe it. If I put the square root of 3 in my calculator, it's a terrible decimal. It's like 1.6 something, and it goes forever. But if I put the square root of 16 in my calculator, it equals 4. And now I have a nice coefficient of 4. The square root of 3 stays as the square root of 3, giving me an answer of 4 root 3. Cool. I want to do something with that question. I want to show you a common mistake that happens for this question. So a common mistake, and if you worked ahead, you might have done this. A common mistake is that 48 is divisible by 4. So if you did 48 divided by 4, it actually works. And 4 is from our chart. So if you did that, you would have had root 4 times root 12. And the square root of 4 does equal a perfect value of 2. And you'd have 2 root 12. And I've made no mistakes there. This answer is not considered simplified. It's like half simplified. You always want to fully simplify things, which is why I'm stressing find the biggest number that divides into 48. 16 was bigger than 4. So I need to divide by 16, not by 4. If you make this mistake, you can fix it. The way you fix it is by looking at your radical and realizing, wait a minute, 12 can be divided by a perfect square still. 12 could break up to be root 4 and root 3. And that 2 would still be a coefficient. So now I have 2 times the square root of 4 times the square root of 3. If I keep going, the square root of 4 is 2. The square root of 3 stays as the square root of 3. And then I have 2 coefficients. You can combine those coefficients. You have to ask yourself, what operation are coefficients doing? They're multiplying. So what that means is if you have 2 coefficients, you have 2 times 2, which would simplify it to be 4 root 3, which is the same answer as we got up here. Now it's fully simplified. What I want to stress is that this is a lot less steps than this. So when you go to simplify things, find the biggest number that divides in. Don't just start with the easy numbers like 4 and 9. You start all the way at the bottom and work your way up the chart. I know it might feel like it's taking longer, but it's not, because this is the alternative, much harder. Cool. I'll give you the square root of 27. I'll give you a minute to try it on your own. So the first step is all I'm asking you to do right now. Break root 27 up into 2 roots, or 2 radicals. So try to break that into 2 radicals. 27 breaks up to be 9 times 3. Then you calculate the one that's perfect. You do not calculate square root of 3. It's a terrible decimal. We don't want decimals anymore. We only want to calculate the square root of 9. It equals exactly 3. And then you have root 3 still remaining. That simplifies to be 3 root 3. You don't want decimals. You should have almost no decimals in this unit. Okay, everything's either a radical or a whole number. One or the other. Don't change things to decimals. All right. Last one, we have root 50. So if we take 50, we could have broken it up into 25 and 2. I should be still putting my time signs. I'm not, but I should be. The square root of 25 equals exactly 5. The square root of 2 stays as the square root of 2. Your answer would be 5 root 2. Yes, sir.
Can I go to the washroom?
Yes, sir. All right. Those are the easier ones. So that's about as easy as they're going to come. They can get a little trickier. The way they can get trickier is if you look at all those questions we currently had, you'll notice that they all had the same index. So the index is that little tiny number. The index on this one was an invisible 2. The index on this one was an invisible 2. The index on this one, an invisible 2. And the index on this one is an invisible 2. So what happens if you don't have an index of 2? Does it change the question? Does it change how we approach it? Like, what happens? So if you flip over to the other page, you're going to see that we have 4 questions with indices or indexes, I don't know, different little numbers. You'll see that the first one has an index of 3, the little tiny number. Second one, index of 3. Third one, index of 3. Fourth one, index of 3. All different. All right, so how does that change your question? Well, in the previous questions, what we were doing is we were taking our numbers and we were breaking them into perfect squares times something. The reason we were doing perfect squares is because the index was 2. So we were doing perfect exponents of 2. If the index turns to a 3, instead of doing perfect squares, we need to do perfect cubes, which would be things to the power of 3. So now we need another chart. This chart will be things that are to the power of 3. Yes, sir. So 2 to the power of 3 is 8. 3 to the power of 3 is 27. 4 to the power of 3, 64. 5 to the power of 3 is 125. 6 to the power of 3, I'll stop here, is 216. Typically, you don't need to go as many because the numbers get so big so fast, right? If you did the first 10, that's almost always enough. Look. Oh, I do. I'm going to need the first 10, so I'm going to keep going. You can write these down for yourself then, too, so you have a chart somewhere. 7 to the power of 3 is 343. 8 to the power of 3 is 512. 9 to the power of 3 is, I don't know, has somebody calculated for me? 600 and something. No, 712? So 9 times 9 times 9.
729.
29. I was close. And then 10 to the power of 3 is 1,000. Again, you could make this chart yourself, right? So when your test starts, I would make this chart myself. On my back paper, on a piece of scrap paper or something, I would write these out. And I calculate the first 10 and the next first 10. We usually don't do anything higher than index of 3, but it's possible. If I had an index of 4, I'd do a to the power of 4 chart. If I did an index of to the power of 5, I'd do a to the power of 5 chart. With those numbers, you only have to do like the first 3 numbers. You'd probably be good. Because the numbers get so big so fast. Yes, sir.
My mom's here.
For sure. Yeah. Take care. Now that we have a new chart, the process is the exact same. So I'm looking at 375. I want to find the biggest number that divides into 375. I'm going to start at 343 on my chart because that's the biggest number that's less than 375. So I go 375 divided by 343, doesn't work. I go 375 divided by 216, it doesn't work. I go 375 divided by 125, it does work. And I can now rewrite this to be the cube root of 125 times the cube root of 3. All right, something I want to stress. Notice that my index started as a 3. Notice that all my indexes are still a 3. If you don't write an index, a lot of people forget to write the index. If you don't write the index, you're telling me it's a 2. So you have to put something there, and it has to be the same thing as the question started. The index will never change when we're simplifying radicals. Perfect. The reason I chose these numbers to break into is because the cube root of 125 can be calculated. In your calculators, you're going to have that button in different spots. Some of you might actually have a cube root button, like a 3 and then a root sign. And some of you might have an X and then a root sign. If you have an X and then a root sign, you have to type the number 3 first and then hit the root sign button. And what you're telling your calculator is 3 is X. And you're kind of helping it out. Even that might not work on some of your calculators. So I would highly recommend you test right now if you can calculate the cube root of 125. If you can't calculate that, I will help you out. Yours would be, ideally, you're all getting this type of calculator, right? So for Math 10C, you will need one of these calculators. So if you have one of these, your button for cube root, you want to hit the number 3, and then you want to hit math. It's the third button down, so hit math. And then the 5th option you'll see is like a little X with a root sign. So you want to hit that little X with a root sign. It's your 5th option. And for me, my calculator then shows me the 3rd root. It might say 3 and then X and then root, and that's the same thing. And then go 125 and hit enter. And it should tell you that the 3rd root of 125 is 5. The leftover would be the cube root of 3. If your calculator didn't get that, I'll help you out after. We have so many different calculators in the room, it's hard to know which buttons need to be pushed. That's why you're going to get encouraged to get one of these, so that everybody has the same type of calculator. It should say TI-83 or TI-84 at the top. If it doesn't, then you need to get one of these. Bueno. Has anybody else figured out, because the calculator is one way to do that calculation, but there's a quick way to know what it would have been. Has anyone figured out like the quick cheat to know what the cube root of 125 was going to be? The quick cheat to know is to look at your chart and check on how 125 got made. 125 got made by doing 5 cubed. That means if you cube root 125, you're undoing that to the power of 3, which is why it equaled 5. So you'll notice the number always matches up from your chart. Right? Like the cube root of 64 will be 4. The cube root of 343 will be 7. And so if your calculator is not working for you, you can kind of cheat your way through a little bit on those calculations. All right, let's try F. So I got the cube root of negative 2,000. My first job, break 2,000 up into 2 numbers. If I look at my chart, 2,000 divided by 1,000 will work out perfectly. So I now have the cube root of negative 1,000 times the cube root of 2. Notice that it's a cube root on both sides still. If you calculate the cube root of 1,000, it equals negative 10. The cube root of 2 remains where it is. And you're done. That's a good question. So when you're simplifying, your negative, if it's underneath, should come out front. So it goes with the coefficient, and that's okay. Yeah. Mm-hmm. It's just like the standard way to write it. I don't know. There will be like math standards that we write things. Like a math standard would be you don't put an index of 2. You don't write the 2 in there. But if you put the 2 there, it's still kind of okay. So the math standard for this would be the negative goes with the 10. G. I got 512. I need to find the biggest number that divides into 512. It has to come from my cube chart. If I look at this, 512 is actually on my cube chart, which I'm hoping is not a mistake. Good, it's not a mistake. I started to really second guess myself there. 512's on my chart. So what I tend to see is people get good at the routine of how to do these questions. So they take 512 and they break it up into 512 times the cube root of 1. Which is kind of funny, right? Because you still have 512. Like, you really didn't change anything. You just multiply by the cube root of 1. Because when you did 512 divided by 512, it equaled 1. You actually have two perfect cubes there. 512 is a perfect cube. It equals 8. 1 is also a perfect cube. It equals 1. That means what you have here is 8 times 1, which equals 8. And you no longer have a radical at all. And the reason you don't have a radical is because you started with a perfect radical. You could have just calculated the cube root of 512 and got 8. And it is a bit of a long way to get there, but we got there. Fantastic. The last one, H, and this is the hardest one we do, hands down. The reason it's the hardest one we do is because there's already a coefficient there, which means it's already a mixed radical. But it is not the simplest mixed radical. So the simplest mixed radical has a radicand. That's the number underneath the root sign. It has a radicand that cannot be divided by a perfect number. And if you look, 24 actually divides by 8. That means I can take this cube root 24 and I can turn it into cube root 8 times cube root 3. But that coefficient that you already had is still there. It's still right out front. So what I've done is I've turned this question from 2 times the cube root of 24 into 2 times the cube root of 8 times the cube root of 3. The reason I did that is because the cube root of 8 can be calculated. The cube root of 8 equals 2. So I now have the original 2 times a new 2 times the cube root of 3. And I have two coefficients out front. Coefficients mean multiply. So to finish this question off, I multiply these. Two times 2 equals 4. The cube root of 3 remains a cube root of 3. My final answer is 4 cube root 3. That is as hard as it will get this year. That's when you already have a coefficient and you're trying to make it even simpler. You're just going one step further. Cool. What I'm going to do is to go from mixed into entire means to take something that has a coefficient and turn it into something that has no coefficient. Right, that's going to be our goal. Honestly, I'm just going to show you a couple steps, and you can follow those exact same steps every time, and it'll work, which is kind of nice. So I'm going to just jump right to example 1. And here's the steps I use to convert from mixed to entire. To go from mixed to entire, I don't want a coefficient anymore. So what I do is I take that coefficient and I put it underneath the radical sign. Because it's a coefficient, when it goes under the radical sign, I'm timesing by it. So you now have underneath the root sign 2 times 7. Now, in math, and in future units, you're going to hear me say it a lot. There's always a balancing act. Like you got to balance things out. You've heard this before. So in previous classes, you've heard things like what you do to the bottom, you do to the top. You've probably heard that. What you do to one side, you do to the other. You've probably heard that, right? They're balancing things. So when you move something in math, there has to be a balance, a way to make it equal. When you put something under a root sign, the way you make it equal is by giving it an exponent. The exponent has to be the same number as your index. So on this question, what's my index? That means my exponent is now a 2. So I'm going to write this a little neater. I had a 2 as my radicand. I moved the 7 underneath, and I gave it an exponent of 2. That's how I balance it. You now have no coefficient, which is exactly what we wanted. You need to calculate your new radicand. So you're not actually calculating the square root of this, you're just calculating your new radicand value. That means this is the square root. And if you do 2 times 7 squared in your calculator, you should get 98. Remember on your calculator to do BEDMAS. So you do 7 squared first, because exponents happen first, and then times by 2. That's converting into an entire radical. Honestly, it's easier. Unfortunately, it's not as useful. So it's the easier thing, but we need it less. If we look at B, we're going to try the same thing. Yes, sir.
For the practice sheet,
Yep.
on B, it's 3 to the square root of 7 for that. Can you just like put a coefficient in front of the 3?
3 squared root of 7?
3 squared is 9, and 9 times 7 is 63.
Yep, that works. So if I'm looking at this guy, I have a coefficient. I want to go to entire, so I want to move that coefficient so it's no longer here. When I move it, I multiply. To balance out the fact that it's now being square rooted, I have to give it an exponent. The exponent is the same number as the index, which is 2. Right? The exponent is the same number as the index. And my index was an invisible 2, right? This means I have the square root of 3 times 8 squared. I move the number, I give it an exponent. If you calculate your new radicand, you're going 8 squared times it by 3. I think you get, 192. I'm pretty confident that. 192. Make sure when you get that, like that 192, it came from calculating this. So I went and put that in my calculator, and I put brackets around my little 8, so I did it properly. And that will equal 192. All right, C has a trick to it. With C, there's a rule you guys would have learned a long time ago. It would have been that you can't square root negative numbers. So when you have a question like this and you want to convert it into an entire radical, because it's a square root, only the 4 is allowed to go underneath. The negative is not allowed to go underneath because it's a square root. If it had been a third root, the negative could go underneath. It's kind of a weird little trick. So square roots, it stays out front. Odd root, so if it was like a third root or a fifth root, then the negative could go underneath with the number to the radicand. We move our 4 underneath. We give it an exponent of 2. This means I now have 6 times 4 squared. You throw that in your calculator. 6 times 4 squared in your calculator is going to be... What'd you get, 196? 96? I'm trusting you. And again, notice that the negative is out front. Last one over here. I want to turn it into an entire radical. I move the coefficient. I give it an exponent. That means I have 5 times 10 squared. Your new radicand would be 500. Honestly, you figure out the pattern, and it's going to be the easiest thing you do. Once you got that pattern, it's going to be nice. Without the pattern, it's very confusing. So if you don't understand the pattern yet, it might still feel very confusing. Once you see that pattern, it's going to be nice. Move the coefficient, give it an exponent. If we look down here, you'll notice our index starts to change. So when I move the coefficient and I give it an exponent, the exponent on that is a 3 now, not a 2, because the index is a 3 now. So it has to be the same exponent as the index. So this now changed to be the cube root of 3 times 2 to the power of 3. That's key, right? Notice those values are the same. That means I have the cube root of 70. No. The cube root, 24. You'll also notice that if I start with a cube root, my answer ends as a cube root. So if the index starts as a 3, it ends as a 3. The index shouldn't change during your questions. F. I'm going to take the coefficient, move it underneath, multiply by it. This is going to be 4 to the power of 3 because the index is 3. Meaning that I have the cube root. Oh, man, that's going to be a lot harder to do in your head. Anyone got 4 to the power of 3 times 7?
448.
Thank you. Save me. So I took the coefficient, I moved it underneath, I cubed it, I then calculated 7 times 4 cubed, right? That's how I'm getting 448. Your calculator, remember, your calculator might not know bed mass. So you might have to do this a little differently in your calculator. You might have to do the exponent first. So go 4 to the power of 3 first, then times by 7. Your calculator might need you to do it in that order, because your calculator has no bed mass. The last one, notice that it's negative. This time the negative can go inside. The reason the negative can go inside is because it's an odd index. If the index is odd, the negative can go inside. 2 times negative 5 to the power of 3. If you calculate that, you should get negative 250. The difference. Square root is correct. You can't square root. This is now a cube root. Cube root's allowed, which is confusing, right? It's like, wait, you just gave me a rule and then you broke your rule. So our rule is that odd indexes If this is an odd number, you can put the negative underneath. If it's an even number, you can't. The reason is what a square root's doing is it's taking a number, say like 9, and it's turning it into a number that you could then go 3 times 3 equals 9. Odd numbers can't be square rooted because there's no two numbers that are the same that would multiply to be an odd number. Because the only way you multiply to be an odd number is if one's positive and one's negative. So it doesn't work out, which is why this like rule exists. It's kind of weird, but it makes sense when you think about what rooting is doing. The last one is H. Look at the index. The index is even, which means the negative stays out. So only the 2 can go in. Because it's an even index. So I have negative 4th root 3 times 2 to the power of 4. You throw that in your calculator, and you should get 48. All right. I think when people are nodding means you knew what you were doing to get there. Like I said, honestly, once you get used to this pattern, it's way easier than the other one. But the other one is definitely the one you want to get better at. Yeah.
Okay, wait, so the last question, the negative is inside the root. So is that just because it was on?
Yep. So the difference between the two questions. This one, the negative came in. This one, the negative stayed out. The difference is the index. Even index, it stays out. Odd index, it comes in. Fantastic.